In this demonstration we'll have a look at the process of cracking. We're going to be using as our starting alkane source liquid paraffin. Cracking is a process where long-chained hydrocarbons are split up using heat and a catalyst into smaller chains and usually evolving ethene. The catalyst we're using here is aluminium oxide powder, but in a school situation you might want to use broken pieces of porcelain pot. Porcelain contains aluminium oxide in its surface layers. The setup is a bit fiddly. You need to put some mineral wool or some glass wool, whatever is appropriate in your establishment, into the bottom of a boiling tube. Soak it with liquid paraffin, pour out the surplus liquid paraffin and clamp horizontally at the neck. The idea behind the glass wool is to hold a reservoir of the liquid paraffin horizontally. Slide in some aluminium oxide, that's not an easy thing to do. Put in a delivery tube into a trough of water into which you've got some sample tubes and bungs ready to go. In other words, submerge the tubes into the water and above the bungs ready to simply pop onto the bottom. Start by heating the aluminium oxide. If your clamp isn't at the end of the boiling tube, you're going to burn the rubber or cork on the clamp itself, so that's why you need to clamp it at the very end of the boiling tube. Heat it strongly. Once it's heated strongly, flick the flame from your Bunsen burner into the liquid paraffin to vaporize it so that the hot vapor, hot gas from the liquid paraffin can come in contact with the catalyst to do its chemistry. The gases are then taken through the delivery tube into the boiling tube. Remember that the first gas that comes out is simply expanded air, so let the first few bubbles or first few tubes of gas go to waste and then collect what should be ethene gas. You may notice that the surface of your trough of water becomes a little oily. These will be the smaller molecules of alkane that have passed down and have condensed into the cooler water, and oil of course floats on water. Of course the oil slick could be some unreacted liquid paraffin as well. When you finish collecting your ethene gas, don't forget to remove the end of the delivery tube out of the water, otherwise you'll get suck back of the cold water onto the hot glassware and it's likely to shatter. The standard test for the alkene ethene that you've collected is it will decolorize bromine water and decolorize acidified potassium manganate 7 solution. It's a very similar setup to the reaction for the production of ethene gas from ethanol by dehydration. When using acidified potassium manganate 7, the solution should be very, very pale to start with. Potassium manganate 7 doesn't require a great deal of solid to make a very saturated in terms of color solution. So a very dilute solution of potassium manganate 7, acidified with sulfuric acid, dilute sulfuric acid, not dilute hydrochloric acid, or you may evolve some chlorine gas. Just take a few drops of it, put it into the tube containing the ethene gas and shake. If you've got a double bond present, it should oxidize across the double bond, forming the diol, and you'll get a color change from pink to colorless. If you don't acidify it sufficiently, you'll get a brown solution of MnO2 being formed in the bottom of the tube. With the reaction with bromine water, it's the HOBr molecule that is present in bromine water that is the reagent. There is an equilibrium shift, so the bromine color of the solution will decolorize as the HOBr adds across the double bond. If you have enough tubes of ethene gas left over, it's always a good idea to show that ethene will burn. Combustion of ethene gas is not a test for ethene, it's a test for a fuel.